All right, in this lesson, we're going to be covering something called vectors. Now, what a vector is kind of like in geometry, you had something called a ray. Let's say, but we're graphing it on an XY coordinate plane. So let's say we have a ray that looks like this. Now, as long as this has a direction and a size, this is called a vector in math. Now, vectors get kind of in depth, and it's going to look something brand new, but we're going to keep it very simple. Remember, we can do a couple things with this, that we're not going to call this array anymore. We're going to call this a vector. We can do a couple things. If we draw, let's say that we know that this vector is approaching a certain point. Let's say it's approaching, it's going at a degree. If we were to draw a right triangle and we say this point right here, let's say this point is 6, 4. That means I've gone 6 units this way on my x, and I've gone 4 units up. This is called a vector with direction, and the size of this vector, this hypotenuse right here, is called the magnitude. Magnitude in vectors refers to the size. It's the distance from where it starts to where it is approaching or where it is going. Now, if I wanted to figure out this, the length right here, as you can see, I just drew a triangle. And if I have a triangle, I could just use Pythagorean theorem to find this number right here, which is called the magnitude. If I wanted to know the direction of my vector, I would find theta. Theta is the degree in which the vector is headed. So that's kind of vectors summed up all into one, but it gets a lot more in depth as we start moving on. Let's look at the example that I give you. I give you, first off, a vector that starts at 3, 2, and it goes to the right 8, 2. So this on the x-axis has moved 5 units. And this is called the magnitude. The magnitude is the size, how big it is. The direction, we just know it's gone to the right. It's 0 degrees, but we know it is moved to the right. So the direction sometimes is theta, which tells you the angle which is moving, or if it's not even moving at an angle, we just know it's going 5 units to the right. I also say in the notes now, we have this vector. Let's call this vector no, this isn't the same one. This is going to be a different one. But let's just take another vector that's moved 5 units. The way vectors are labeled, a couple different ways. The first way that they are labeled is, let's call this vector z. This vector illustrates that it is a vector, that it has a magnitude and direction. But you just put in an arrow over it. Remember in geometry when you put an arrow over a ray? Same kind of thing. Now also on the first page of notes, I talk about a scalar. A scalar is, technically when you're multiplying a vector, you're extending it out. A scalar has magnitude. It means it increases or decreases in size, but it doesn't have any direction. So what I'm going to do is, let's say I go 20 units to the right. Now, scalars we're going to talk about a little more in depthly, not now, but the next class. But let's say this vector is 5 units. Now it's gone 20 units. Technically, it has traveled I say in the notes 4 feet per second, but let's say 4 units on over 1 unit of time. All you got to know is this, if it starts off at 5 and then it goes to 20, it's 4 times the size. It's gained 4 units. It's gotten bigger, which means scalars get bigger or smaller. They don't change direction or anything. It just increases or decreases. But for right now, I don't think you have any questions about scalars. So right now, we're not going to worry about scalars too much. I wrote this in the notes, but when I gave you your assignment, the worksheet, I didn't include any scalars. So we're just going to focus right now on vectors and the magnitude of vectors. Okay, remember this right here is the magnitude, right? This is the magnitude. How would I find this side right here? Well, I would take this side, because I would just use Pythagorean theorem. I would say a squared plus b squared equals c squared. So I'm going to get 36 plus 16, and then I'm going to get c squared. But how do I get rid of that square? Well, you're going to square, boom, root both sides. So to find this, you're taking this squared plus this squared and square rooting, which is exactly the formula. So look at the formula in the next page. It says let's just call it vector u. The magnitude, or sometimes it'll have 1, or sometimes it'll have 2. Both of these mean the same thing. The formula for this is you're going to square root a squared plus b squared, because the vector is the magnitude is the size. And the way you find the hypotenuse is just basic Pythagorean theorem. So let's take an example. And we have a magnitude headed towards this point right here, 5, 5. That means it's gone 5 units and then 5 units. Now, if you remember, the magnitude is going to be the square root of the Pythagorean theorem. But if you notice right here, this is a 45, 45, 90-degree triangle. So this is x, x, x root 2. So the magnitude of this is 5 root 2, or a squared plus b squared, simplify that root to get 5 root 2. The next thing we're going to talk about, magnitude, first off, is the size. So whenever it's asking you to find the magnitude, it's just asking you for this formula. The next thing we're going to talk about is the correct way to label these. The correct way to label these is called component form of a vector. And whenever you have a vector, you travel a certain amount of distance on the x and a certain amount of distance on the y. So let's say wherever you start with, you change your x and you change your y. So you're technically, to go from here to here, you've done a change in your x, you've done a change in your y. Now, the way that component form is, it's the name of the vector. Think of whenever you're trying to name a vector and describe where it's moved, it's called component. form. And sometimes it's like this. Let's go back to that example where this is 5, 5, and this is 0, 0. Well, if you were doing this, you know that this is moved 5 units to the right and 5 units up. So this is called component form, 5, 5. Now, another way that they can write this is, instead of these parentheses, they can give you little weird bracket-looking things. And another way that they can write this is, sometimes in pre-calculus, they're going to call your x-axis technically your I-axis. And they're going to call your y-axis your j-axis. Or I think they do lowercase lowercase j. So this can also be written as 5i plus 5j. But they would have to name the vector. So let's call this vector, this is point A, and this is traveling to point B. So we're going to call this vector AB. All three of these are exactly the same. This is the same as this, which is the same as this. There's 1, 2, 3 ways to name component form. Now I give you an example in the notes. I say find a component form of vector AB. So, and I give you, it starts off at 4, 4, and it's traveling to -7. It's traveling to -7 on the x and down 8 on the y. Write this in component form. Well, let's look how much it's traveled. It's traveled a certain amount of units to the left and then a certain amount of units down. Technically, you could just call this a right triangle. So it's traveled -11 units to the left, and it's traveled from 4 down to -8, -12 units down. So if they give you a vector in blue and they ask you to write it in component form, you can either write it like this. Let's just call this vector point A, and it's traveling to point B. We're going to call this vector AB. You can write it like this, -11, -12. That's how much it's traveled. Or, same thing, but instead of these parentheses, I can use these brackets, -11, -12. Or vector AB on an x, on an I and j is -11i minus 12j. All three of these, 1, 2, 3, are exactly the same. This is called component form of a vector. And then I'm going to give you 3 different example problems on what to do. And I'm just asking you to write the vector in component form. So you're going to write it, we're going to mostly write it like this, because most of the time vectors are written in this way. Sometimes they're written like this. They're not usually this, but just know that all this is the same. Most of the time they're written like this. So that's the way that we're going to write it. All right. Let's look at the very first example. I have a vector. And I don't know where it's headed to, but I know it's moved 28 degrees up. Theta is 28 degrees, and the length is 15. I have to write this in vector form. I need to figure out where it is traveled to. So what I'm going to do is I'm just going to create, and this is what you're always going to be doing, you're going to be creating a right triangle. Now let's do SOHCAHTOA to find how far it is traveled up. We know it's 28 degrees, but let's find the distance that it's traveled up. So I'm going to go, this is opposite in hypotenuse. So I'm going to go sine 28 equals x over 15, cross multiply, x equals 15 sine 28. Let me get my calculator. So I'm going to go 15 sine 28 equals 7.04. So x is, my y is 7.04. Okay. Now I'm just going to do Pythagorean theorem to figure out this side. A squared plus b squared equals c squared. So I'm going to go 15 squared minus 7.04 squared, and then I'm going to square root my answer to get 13.3 more or less. Okay, so if I write this in vector form, vector m has moved approximately 13.3 units, 7.04 units up, and its magnitude is already stated. The distance is 28 degrees. It's moved up 28 degrees, and this is component form, or think of component form as describing the vector. Okay, next one. Next example question is going to be RS. All right, so I have a vector R, and it's traveling to S. And this shows -6, 2, and R is -4, -9. So this has traveled a certain amount of units down, and then a certain amount of units to the right. Well, if it's -6 and it's traveled to -4, it's traveled -10 units down. Oh, I'm sorry. Sorry, that's my x. This is -6, and it's gone to -4. It's traveled. Oh, wait, I'm sorry. Yeah, that is right. -10 units down. It was at... Blah, 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 blah. Let me redraw this. It's actually traveled 11 units down. Let me redo this. Sorry for the confusion. This is -6 and +2. This way down here is -4. Let me draw that better. And 1, 2, 3, 4, 5, 6, 7, 8, 9. -9. All right, so the distance from here to here. This is a better representation. So this point is -4, -9. So this has traveled, if I'm at 2 and I drop all the way down to 9, I have traveled 11 units down. And I have traveled, if I'm at -6, I go boom, boom, I've traveled 2 units to the right. So what are they calling this vector? RS is 2 units to the right, -11 units down. If I wanted to find my magnitude, I would do Pythagorean theorem to figure out this side. Or you can write it like this: RS is 2I minus 11J, because this is where it started, this is where it finished. Okay, now the very last one, which is number 3. Okay, look at number 3. It tells you your magnitude is 23. So what that means is the length, the size is 23, but it's traveled 162 degrees. So it's going to a certain point. The distance, or the length, is 23. It's traveled 162 degrees. We gotta find where it started. If it doesn't say anything where it started, it starts at 0, 0. So the very last thing is I have to find my reference angle. So if I were to do 180 minus 162, I'm gonna have a reference angle of 18 degrees. Once I know my reference angle, now I can find my x, because I could use basic SOHCAHTOA like I did in the first one. And then my y, I can use SOHCAHTOA or Pythagorean theorem, and then I can write it in component form. Okay? Let's look at the last one. This is going to be a unit vector. Unit vector is, oh wait, no, it's not a unit vector, sorry. Negative 2i plus 5j. So negative 2i plus 5j is up here. Find its magnitude. This is negative 2, positive 5. So look, if I just draw that basic right triangle, I have negative 2 and 5. So a squared plus b squared equals c squared. So I'm going to have 4 plus 25, which is the square root of 29, because remember when you square root it, but remember the very first page of notes. I'm going to bring this back here, because technically I did a squared plus b squared, and then I square rooted to find the size of it, to find the magnitude. But look here, remember this? The magnitude of any vector is a squared plus b squared, because you're square rooting it. And that, ladies and gentlemen, is the end of the lesson.